Okay, so today's lesson, we are talking about something called a piecewise function, okay? Now, I can guarantee a lot of you have not seen this before, so make sure you're paying attention, okay? The biggest thing that you can use to remember is that word piece is in piecewise. That means that there are going to be pieces of your graph, okay? We're no longer going to be dealing with one fancy, nice, straight line anymore. It's going to be a piece of a line and another piece of a line, okay? Now, how that happens is you're basically going to have two functions in one, okay? Now, when you see a piecewise function, it's going to look like this, okay? Now, the number of lines in your function determines the number of pieces. So, in other words, this one has 2 lines. Do you guys agree? So how many pieces is it going to have? 2, right? So let's label this piece number 1 and this piece number 2. So now, when you guys are graphing your own lines before, right? When we had like f of x equals x minus 2. Let's write that over here on the side. When f of x was equal to x minus 2. When you guys would graph that, you guys would draw it with arrows on both ends, right? Because it continues on forever for all of your x values, correct? A piecewise function does not do that. So at some point in your function, it changes. And in this case, the change happens at 0. So what we do is we look over here on the right, and this defines what part of your graph is following which piece, okay? So when your x values are smaller than or equal to 0, in other words, your first piece, the function is going to be f of x equals x minus 2. Now I want you to look over on the graph. When your x values are less than or equal to 0, do you guys agree that your x values would be 0 or negative? So that means that to the left of 0, this would be considered piece number 1, okay? And the function that you get is f of x equals x minus 2. Let me show you where all of this comes from, okay? So the x minus 2 that you see in your function comes from the first piece up here. So go ahead and highlight those two. And then your x is less than or equal to 0, defining where your function exists, gets carried over to this section, defining where piece number 1 happens. Now, what I want you guys to notice is all of the x values to the left of 0, they're all negative. In other words, all of these x values are less than 0. Do you guys agree? So that's why our piecewise function for the left side for piece number 1 is to the left of 0. Okay? Now, the second thing I want you to notice is that it's a closed dot at 0. Why would x being less than or equal to 0 be a closed dot? Nathan? Good. Circle that, guys. If you ever have less than or equal to, it's going to be a closed dot. Now, the next thing I want to talk about is how they got this line. Like, how did they know that our line was down there? We know it has to be to the left of 0, but how did they know that our line existed down there? And that's just simply by knowing what the graph of that equation looks like. So in this equation, f of x equals x minus 2, what's the y-intercept? Your b value. It's negative 2, right? What is the slope? 1. So you guys agree that I should start at negative 2. Do you guys agree that that y-intercept is negative 2? Yeah. And I should be going up 1 to the right 1? Mm-hmm. But remember, if you move up 1 and to the right 1, you're going into a territory that does not belong to piece number 1. So instead, we're going to go down 1 and to the left 1. Down 1 and to the left 1. Okay? All right. Piece number 2. Piece number 2 was defined for when the x values that were all bigger than 0. Okay? So when x is larger than 0, that means we're going to be dealing with the values to the right of 0. And our function is going to be 2x plus 1. Because in our function, it said f of x equals 2x plus 1 when x is larger than 0. So in other words, we've just created 2 different pieces from one function. That's why it's called a piecewise function. Now, let's find out how they got this line, okay? First of all, why is it an open circle for this problem? Why is it an open circle here? Hunter? Good. It's a greater than symbol with no equal underneath, right? So it's just going to be an open circle, and we're not going to fill it in. My y-intercept is what for this equation? My b value. It's 1. So do you see how my line is starting at the y value of 1? And then my slope here is what? My slope here is 2. So if my slope is 2, I'm moving up 2, and then where? To the right 1. Do you guys see that? So up 2 to the right 1. Okay? So that's how they generated this line. Okay? Now, the first part of this lesson, we're just going to be evaluating different points on these lines. And then it gets more difficult where we're going to be graphing them ourselves and then coming up with the equations ourselves. Okay? All right, so let's talk about when we're evaluating these functions ourselves. So if we were to evaluate a piecewise function at these three values, x equals 0, x equals 4, and x equals -3, you first have to define, okay, what piece does your value belong to? And then you have to evaluate the function, okay? So let's start with x equals 0. If our value is x equals 0, okay, this piecewise function has two pieces. We'll label it piece 1 and piece 2. If x is 0, guys, which piece am I going to use? The first piece or the second piece?
The second piece.
The second. Why? Alicia? That's less than or equal to. Yes. Why does it fit here and not here, though? Yep. Good. This one does not have the equal sign. Do you guys see that? So if your value is 0, imagine we put 0 here. Is 0 less than or equal to 0? Yes. Is 0 greater than 0? No. It's only going to fit into one of these two pieces. So 0 only works for this second piece. Do you guys agree? So write a 2 next to 0. We're going to be in piece number 2. So if we're in piece number 2, my function is f of x equals x minus 2. We're going to access this piece of the function. We're going to ignore 2x plus 1 because that's part of piece number 1. Do you guys see that? And we're only going to use f of x equals x minus 2. So let's write that down. F of x equals x minus 2. Because that was the second piece of our function. Now, it's telling you replace x with what? 0. So plug in 0. F of 0 is going to be 0 minus 2, which is -2. Let me do one more and then I'll take questions. If x was equal to 4, okay, if I were to replace x with 4, guys, which category would it belong to? Would it belong to piece 1 or piece 2? Melanie? Piece 1. Why? Very good. 4 belongs bigger than 0. It's not less than or equal to 0. Do you guys see that? So when x is 4, we're no longer dealing with piece number 2. We're dealing with piece number 1. So put a 1 next to it. And the function for piece number 1 should be f of x equals what? 2x plus 1. Do you guys see how that works? Now, what am I replacing x with for this example? 4. So you're going to write f of 4 equals 2 times 4 plus 1, which is 8 plus 1, which is 9. Go ahead, Hunter. Okay, I got it from right here. Okay, so the 2x plus 1 came from that first piece. Okay, so our function is equal to two different things depending on the x value. So you have to determine, first of all, okay, what piece does this x value belong to? And then secondly, you have to plug it in and evaluate it at that function. Okay, if x was equal to -3, which of those two pieces, piece 1 or piece 2, would -3 belong to? Alec? 2. Very good. Why? Good. -3 is less than or equal to 0. Excellent. So it belongs to piece 2. So what function am I going to be evaluating? What? No. Oh, yes, you're right. Sorry. F of x equals x minus 2. And I'm going to replace x with what? -3. So f of -3 equals -3 minus 2. What's -3 minus 2? -5. Okay, questions? Look it over. Go step by step from the beginning to the end of one of the problems and ask me if any part doesn't make sense to you. Nathan? You don't have to label them if you don't want. I always do it because I want to have like a visual of like, okay, where am I plugging in my point into?
Could you label them anything?
Yeah, you can label them A, B, C. You can label them, I don't know, symbols, triangle, square, circle. I don't know. You're like a video game person. What else? Any questions? Yeah.
What if like your x is 1, but where it says x is less than or equal to 0, what if, would there be a question where it's not 0 but it's 1?
Ooh, yes. But, Josh, they would both have to be 1.
And then you have x is equal to 1, so what would you do there? And they're both.
If they were both 1? So nothing would change, okay? You would just, it would like your x values, right? 0 would no longer, would belong to 2, right? Because 0 is less than or equal to 1. And then it would be the same, basically.
Oh.
Okay? But that could happen. Good question. Any other questions, guys? All right. Let's try the next few examples, okay? So we're going to find when f is evaluated at -1. But this function has how many pieces to it now? 3. So let's label them 1, 2, and 3. So let's look at f of -1 first. Where would -1 fall in terms of the 3 pieces that we have? Is -1 less than -2? If we were to replace this x with -1, would it make sense? No. If we were to put -1 here, is -2 smaller than or equal to -1, which is smaller than or equal to 5? It works for number 2. Does it work for number 3? Is -1 bigger than 5? No. So which piece are we accessing when we have -1? Piece 2. So let's write down our function. What would our function be for piece number 2? F of x equals x plus 2. Do we all see where this x plus 2 is coming from? It's coming from the second piece because that's where -1 fits. Yes? Okay. Now, once we have our function, right, single function, how do we evaluate it? Plug in what? -1. So it's going to be f of -1 equals -1 plus 2. What's -1 plus 2? +1. Okay. What about if we had f of negative 2? Alec? Huh? Very good. It's still going to belong to piece 2. Why, Alec? Good. So do you see that equal sign, guys? It says negative 2 is less than or equal to x. If you put negative 2 here, it works. But if you put it here, is negative 2 smaller than negative 2? No, it's the same. So since there's no equal sign here, it doesn't belong to piece number 1. It belongs to piece number 2. Okay? So if it belongs to piece number 2, our equation is still f of x equals x plus 2. And we plug in negative 2. So f of negative 2 equals negative 2 plus 2, which is 0. One more? Yeah. Yes. F of 0. Okay. F of 0. Take the 0. Where does it fit in? Alec? Piece 2. Very good. Why?
Because the other one is 0, 0 is not less than, is not greater than 5.
Good. So what Alec is doing, guys, is he's saying, okay, if 0 were put in piece number 1, 0 is not less than negative 2, so don't put it here. It is between negative 2 and 5, so we're going to use piece number 2. And it's not greater than 5, so we're not going to use piece number 3. Okay? So we're going to use piece number 2. And we're going to say, okay, if x was 0, use piece number 2. My function is still f of x equals x minus 2. Was it minus or plus? It was plus. Okay? Plus 2. So we're going to do f of 0 is going to be 0 plus 2, which is 2. Okay, to make sure that we get it, I want you guys to try the 3 on the bottom and see if you can get them all right. Go. Okay, the answers are up there. Check them and talk. You guys have 30 seconds, go. So why did the last one change? Why was it all of a sudden 40? Hunter?
Because it's 10, and since the second one, or the first one, the last one says x is greater than 5.
Yee.
That's 10 is greater than 5.
Mm-hmm. So because the value of x was 10, it belongs to piece number 3. So my function was f of x equals what, Hunter?
F of x equals 4x.
Good.
And then it's going to be, you're going to plug in 10 to the x values, and it's going to be f 10 equals 4 and parentheses 10. And then it equals 40.
Good, because 4 times 10 equals 40. Very good. Are we okay so far? No. Miguel, what's up?
I am.
You are, but you don't know?
Yeah.
Talk to me.
I'm just confused with x plus 2 is 4x.
Yeah, so all of these are potentials for what your function could be, right? But it just depends on what your x value is, right? So every single one of these values was between negative 2 and 5. So they all belong to piece number 2. But once you try to access 10, 10 does not belong here. Because you agree on a number line, right? Here's negative 2, here's 5. Where's 10? Over here, right? So piece number 2 only exists between these two sections. This is now piece number 3. That's that realm. So you have to use the f of x equals 4x. Does that make more sense? Now, when you were between here, you used x plus 2 every single time. But once you go to the right of 5, you've got to use 4x. Does that help? Okay. Now we're going to try to graph some of these, okay? So graphing a piecewise function. Guys, cross out, describe the domain and range. We're going to save that for a rainy day. Cross out steps 3 and steps 4. So when we're graphing these guys, okay, the most important part is to understand where your break is going to happen, okay? So identify how many pieces this graph is going to have. How many pieces is this graph going to have? 2. Why is it going to have 2 pieces? There's 2 lines, okay? There's 2 functions that we could be equal to for each of these, okay? My first function is y equals negative x minus 4, okay? After Kyle. After her. Y equals negative x minus 4. My second function is y equals x. Now, y equals negative x minus 4. That is going to be the line to the left of 0. Because the x values that are less than 0, do you agree that they fall to the left of 0? And the values to the right of 0 would be the values that are greater than or equal to 0. So everything changes at what value of x? We change from one graph to the next at what value of x, Josh? 0. So I want you guys to go to your graph and draw a dotted line down 0. Just as a reminder, okay, stuff's going to switch when we get to 0. Now, piece number 1 was when x was less than 0. Do you guys agree? And that's going to be this side or this side of my graph. The left or the right? The left. Because these values, these x values are smaller than 0. That means that piece number 2 should be on the right. Are you guys cool with that? Okay. On the left side of my graph, I have to graph the function y equals negative x minus 4. And I got that from up here for piece number 1. How do I graph negative x minus 4? Y equals negative x minus 4. How do I graph something like that? Go ahead, Hunter.
When the x value is going to be on the x-axis,
Okay.
because of the x value, so negative 1 on the x-axis.
So start here.
Yeah. And then we have to pass through negative 4 because that's the y value.
So start here. Gabby, you want to help her out? You start not at 4. You start at negative 4 because that's my what? My y-intercept. So my b value is negative 4. My slope tells me where to move from there. What's my slope here? It's negative 1. Technically, it's over what? 1. Now, negative 1 over 1 means it's rise over run. Do you guys agree? So if my rise is negative 1, where am I moving? Down 1, and then where? To the right 1. Because the 1 was positive. Do you guys see that? The rise is negative 1, the run is positive 1. But if I keep going down 1 and to the right 1, I'm in piece number 2's area. What were we graphing again? Piece 1 or piece 2? Piece 1. Are they allowed to overlap like this? No. So instead, going down 1 and to the right 1 is the same as moving to the up 1, but to the left 1. Negative 1 over 1 is the same as positive 1 over negative 1. So let's go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. And we're going to get a line that looks like this. Do not go into piece number 2's region, though. Because piece number 2 has its own graph, okay? Our x values can only be less than or equal to less than 0. Okay? The last thing I need you guys to check is if this is going to be an open or a closed circle. It's going to be open, okay? So we're going to go ahead and erase the 2 dots we put on this side and erase this middle dot and make it an open circle. We have just successfully graphed piece number 1. I will take questions now. Go ahead, Alec. Huh? Okay, so do you agree that my slope, if I have negative 1, that's the same as negative 1 divided by 1? Do you agree that -1 is the same as -1 divided by 1? Do you agree with that? And do you agree that that's also the same as 1 divided by -1? Okay. That's all I wanted to show you. Now, remember, Alec, for slope, it's rise over run, right? So I'm just showing you moving down 1 to the right 1 is the same as moving up 1 and then to the left 1. Okay? So now for piece number 2, what was my equation for piece number 2? Y equals x. Someone help me graph that. Go ahead, Nathan. Start at 0, why? B is equal to 0. What's m equal to? 1. So if my slope is 1, how should I move? Up 1 to the right 1. Up 1 to the right 1. Am I okay with moving in this direction? Am I in piece number 2's area? Yes. So I just draw a line that continues on forever. Is this an open or a closed circle in piece 2? It's closed because of this guy. And I'm done. So I have successfully graphed both parts. Now, I can already tell you guys, the hardest part is coming up with this vertical dotted line and figuring out where your lines exist. So where you draw your pieces. The easy part is being like, okay, piece 1 belongs here, piece 2 belongs here. Okay? This is the hard part, figuring out where your lines need to go. Questions on this one? Go ahead, Nathan.
You have to say which one, which line. Like,
No, you do not.
you can just draw them.
You can just draw them. Any other questions? Josh.
Will they always be linear?
They will always be linear. Okay, here's a tricky question. Is this a function?
No.
No, no, no.
The initial thought is it's not a function, but it is. What makes something a function? Passes what test? The vertical line test. If I took a vertical line, guys, and I went from left to right, would I ever touch the graph at 2 points? But I get really close to what value? 0. But remember, 0 is open here. So it actually only touches at this point. If what? It doesn't touch, right? So if it's open, this is not an actual point. This is showing you it exists everywhere to the left, but not at this point. So when we get to 0, it's switching. It's going from the blue graph and it switches to the red one. If they were both closed, it would not be a function because they overlap. Okay? All right, cool. Moving on. Let's do this one. Let's do B. So we've got y equals x plus 1 if x is less than or equal to 0, and y equals negative x if x is greater than 0. How many pieces does this guy have? 2. Let's label them 1 and 2.
What if they have like 3 pieces? How do we graph that?
We'll do that one. Okay, here we go. So let's graph piece number 1. Where's my break happening in my graph, peeps? Where's my break happening in my graph? X equals? 0, okay? You always want to look for the number here where your graph is changing. That's where your dotted line is going to go down. So let's draw a dotted line down x equals 0. All right. Is piece number 1 going to be left of that line or to the right of that line?
Going to the left.
To the left. Why?
Because it's,
With arrow.
yeah. It has the equal sign.
No, not because of the equal sign.
Everything less than 0.
What are the x values that are less than 0?
Positive.
The negative ones, right?
Oh, less.
Okay. Which side is piece number 2 going to belong to? The right, because it's saying it's greater than 0. All the x values that are bigger than 0 are over here on the right side. Okay? So piece number 1 will be on our left. Piece number 2 will be on our right. What's the function that we have to graph for piece number 1? Y equals x plus 1. How do I graph y equals x plus 1? Melanie? Put the y-intercept at 1 because my b value is 1. Very good. Then what? You could do that, up 1 to the right 1.
But isn't it like going in the other?
Exactly. It's going into piece number 2's region. So instead of doing up 1 to the right 1, our slope, do you guys agree, is 1? 1 is the same as 1 over 1, which is also the same as what? Negative 1 over negative 1. So we can go down 1 and to the left 1. Now, just as a reference, keep that point. Do you guys agree if I continued this line into piece number 2, it would cross through that point if we continued it?
Yeah.
Okay, but you don't want that point there. Okay, so erase it. Open our closed circle for piece 1. Closed, so leave it. Okay, piece number 2. Y equals what? Negative x. How do I graph y equals negative x? Someone new. Someone different. Melanie?
You start by putting the y at 0.
Uh-huh.
And then you go down
Uh-huh.
1 and to the no, you go up 1 to the right.
So like this?
Yeah.
That looks like a positive slope to me. Hunter?
What I did is that I started at the origin
Yep.
because b equals 0 and then my slope is negative 1.
Uh-huh.
So I went down 1 from 0
You went down 1, and then where?
and then to the right 1.
Good. Down 1 and to the right 1. And this will give me the negative slope that I need, and that's the correct graph. Now, there's something that's wrong with my graph. Gabby?
The red line should have
The red line should have an
an
open circle. Why?
because
It's not equal to. One more example, then we're done. Okay? We have to do one with 3 pieces. Okay. So, in example C, there's 3 pieces. Y equals 1, y equals x minus 1, and y equals negative 2x plus 4. Okay? First thing you need to do is draw your vertical lines. There's going to be vertical line through x equals negative 3. So draw that now. There's going to be a vertical line through x equals positive 3. If it helps, guys, think of the x-axis as a number line, right? The values where x is less than negative 3 over here. Negative 3 is less than or equal to x, which is less than or equal to positive 3 are in the middle. And then x is greater than 3 are all on the right-hand side. That gives us our 3 pieces, 1, 2, and 3. And then we can start to graph them. What's going to be the function for piece number 1? Josh?
You have y is equal to x, no, for y is equal to x plus 1. No, x minus 1.
Nope. For piece number 1. Nope. Y equals 1. So, what kind of a line is y equals 1? It's horizontal. What's my slope of y equals 1? My slope is 0. What's my y-intercept? My b is 1, okay? So if we were to start at 1 and have a horizontal line, it would look like this. Now, we can only be in section 1, so we're going to stop when we get to -3. And is it going to be an open or a closed circle? It's going to be open because it was x is less than -3. In piece number 2, our function is going to be y equals x minus 1. That means I'm going to start, my b value is -1. My slope is +1. So I'm going to start at -1 on the y-axis. I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1 until I get to 3. And I'm going to draw my line all the way through until I meet with section 1. So that's my middle piece. Because it was defined between -3 and +3. I'm going to leave these closed dots on the ends because it's less than or equal to and less than or equal to. And then my last piece is when x is larger than 3. So my last piece is y equals -2x plus 4. So graphing this, okay, I still have to start at 4 on the y-axis. And I'm using my slope of -2 over 1 to go down 2 and to the right 1. But I'm not actually going to draw a line through any of these points because these points are in which piece? They're in piece number 2. I can't start drawing a line until I get to piece number 3, and then I can draw my line through them. It's going to be an open circle at 3 as well. And then erase the points that you drew to get there. Okay, peeps, go ahead. Okay, the next section we are going to be writing piecewise functions for the graph. Okay, so we're given a graph and we have to write the function for it. So first what I want you guys to do is identify where this split happens in your graph and figure out, okay, what are the bounds on x for each piece. So we have this first piece over here, we'll label it number 1, and this second piece over here. And as you can see, they switch when x is equal to 0, okay? So at 0, they switch and they change. Now, to the left of this graph, we'll use black for this one, it's when the x values are less than 0. Now, we're not going to include 0 because there's an open circle in this first piece, okay? So when x is less than 0, we've got this side, this piece. Now, we also have to come up with the equation on this side. So we have, for x less than 0, what's the equation of this line? Well, let's pick 2 points on the line. Let's pick this one and let's pick this one because we're trying to write the equation. So we need y equals mx plus b. So we need to figure out the slope and we need to figure out the y-intercept. Our slope we're going to find by picking 2 points and calculating the rise over run. So to go from this point to the next point, we're going up 1 unit, so plus 1, and we're going to the right one, so plus 1. We put the rise, which is 1, over the run, which is 1, and we get 1 over 1, which is 1. So my slope is 1. My y-intercept is where my graph is crossing the y-axis. Now, this one's easy because it shows me where the y-intercept is. If we're not given y-intercept, remember, you have to use slope or point slope form, not slope intercept form. So we have a y-intercept here. I see that it's 3. This point is 0, 3, so my y-intercept is 3. So my b value is 3. Okay, so I've got m, I've got b, I can write an equation. This equation is going to be y equals 1x plus 3. Make sure you do not write it as 1x though, you simplify it. It should just be y equals x plus 3. Remember, x is the same as 1x. Okay, so now we're done with the first piece. Now we move on to the second one. On this side, these are the x values where x is greater than or equal to 0. We have to say greater than or equal to because it's a closed dot down at the bottom of that graph, okay? And all the points to the right of 0 are the x values for this line. So we know that it must be x values where they're greater than or equal to 0. So now we still have the y-intercept here, so we're going to use y equals mx plus b. Let's pick 2 points and find our slope. So let's pick this point down here, and I see a point over here. And let's count how far we move to get to the other point. So we go up 2 units, so plus 2, and to the right 1 unit, so plus 1. So my slope, remember, is rise over run. So we're putting the plus 2 over the plus 1, and 2 over 1 is just 2. So my slope is 2. Now figure out my y-intercept. This point down here where it crosses the y-axis is 0, negative 1. So negative 1 is my y-intercept. My b value is negative 1. So I have a 2 and I have a negative 1. Let's put them in the equation. It's going to be y equals 2x minus 1. Perfect. So now I have all my components. I can write a piecewise function for this, okay? So we're going to use y, and we're going to say equals. You could also use f of x or y. Either one is appropriate. And let's write the first one. So our first equation was y equals x plus 3. That x plus 3 goes first. So x plus 3 was the equation of the line, but the function was only x plus 3 when x values were less than 0. So we have to put it's x plus 3 if your x values are less than 0. If they're not, then we use the other piece, okay? So that's piece number 1. Piece number 2, we do the same thing. So y was equal to 2x minus 1. That's the equation of the line. So we write 2x minus 1. But only if our x values, then we use this piece, were greater than or equal to 0. Okay, so we're done. Okay, let's move on to the next one. So this next one, we're also given the y-intercepts. And the break in the graph also happens at 0. Okay. So let's use blue for this first piece, and let's use green for this second piece, okay? So for the blue piece, we want to start by defining, okay, what are the values of x for the blue piece? And I see the split happens at 0, so we're comparing x to 0. And these values are all negative, so the x values are less than 0. But this time, we have to say less than or equal to, because this is a closed circle here. So we're including 0 in this piece of the function, okay? So now we just write the equation. It's y equals mx plus b. We have to find the slope. We have to find the y-intercept. Pick 2 points, this point and this point. To get from one to the other, you have to go up 1, so plus 1, and then you're going to the left one, so minus 1. So our slope is m equals positive 1 over negative 1. A positive 1 divided by a negative 1 is just negative 1. So my slope is negative 1. Now we need to find my y-intercept. Where does this graph cross the y-axis? And it crosses right here. This point is 0, negative 1. So my b value is negative 1. Okay, so I've got both of these. Let's write an equation. It would be y equals negative 1x minus 1. Remember, we do not write it as negative 1x. You just want to write it as negative x. So y equals negative x minus 1. That's my equation. Okay, so that side is done. Now we have to do the other side, okay? First thing you want to do is figure out, okay, what are the x values where this second piece exists? And those x values are when x is greater than 0. We do not include 0 over here because it's an open circle at the change, okay? So it's starting at 0, but we're not including 0, so we're going to leave it as just a greater than symbol. And then now we have to write the equation. So we're going to write y equals mx plus b. Find your m. Pick 2 points. Let's pick this one. Let's pick this one. To go from one to the other, you go up 1 unit, so plus 1, and you're moving to the right one. So plus 1 over plus 1. So my m is 1 over 1, which is just 1. Now my y-intercept is this point right here. It's 0, 2. Okay, so my y-intercept is 0, 2. That's 2 then, so b equals 2. So my equation is going to be y equals x plus 2. Oops. Plus 2. Okay, perfect. So now all we have to do is we have to write them together in one piecewise function. So we're going to write y equals, and then we're going to have two lines because there's two pieces. We have negative x minus 1 if x is less than or equal to 0. And we have x plus 2 if x is greater than 0. This is my piecewise function. Okay, moving on. So we have letter C. In letter C, there's 3 pieces, so we know we're going to have 3 different sections. The first section is this one over here on the left, and these values of x are when x are less than or equal to negative 2, because they're to the left of negative 2, and it's including negative 2 because it is a closed circle at the change, okay? And you can see the change is happening right here, okay? All right, so now I have to come up with an equation. This equation is going to be y equals mx plus b. So let's find our slope first. So we start here, we go to here, we're going up 1, and we're going to the left 1. So positive 1 over negative 1, so my slope is going to be negative 1, okay? Now, for the y-intercept, we don't see the y-intercept here, okay? So what you have to do is you have to use point-slope form. So we have the slope already. Just pick any point on your graph. So I'm going to pick this one right here. And this point is negative 2 comma 0. So let's use that point. Let's use the slope and let's see what we can get. So we're going to do y minus y1, which is from your point. So we're going to use the 0. So y minus 0 equals, then use your slope, which is negative 1, and use x minus your x1, which is negative 2 here from the point. So it'd be x plus 2. Okay, so we have y minus 0, which is just y, equals negative 1. Distribute that to both terms. So it's going to be negative x minus 2. You're just changing the sign, okay? So this is our equation. Normally you add something over or subtract something over from the y side, but in this case it was subtracted by 0, and y minus 0 is just y because you're subtracting nothing from y. Okay, so we did the first piece. We have a limit on x and we have an equation for the function. Let's do piece number 2. These are easy whenever they're horizontal lines because you know it must be in the form y equals some constant. So I see it's starting from negative 2 and it's going to 1, okay? So it must be, x must be greater than negative 2 and it must be less than 1, okay? These are my bounds on x. Now, I know that it's 2 less than symbols and not less than or equal to because the 2 circles here are open, okay? So now we just have to write an equation. Well, what is the y value that it's at? And the y value here is 2, okay? So your equation is y equals 2 because it's a horizontal line, okay? Remember, horizontal lines are in the form y equals a number. Vertical lines are in the form x equals a number, all right? So then we move on to the last piece, which is this piece over here. We'll call it piece number 3. And we have to create our limits on the x. So our x limits, our x must be greater than or equal to 1 because all the x values are to the right of 1. Okay. And then secondly, we have to come up with the equation. So we're going to use y equals mx plus b. Let's find our slope. Our slope here, let's start at this point. Here's another point. We're going up 2, so plus 2. To the right 1, so plus 1. So your slope is going to be 2 over 1, which is 2. Okay? Your y-intercept is not given. Okay? So we're not going to use slope-intercept form. Take your slope, pick a point. Let's use this point right here. This point is 1 comma negative 1. And let's use point slope form. So we're going to do y plus 1 equals 2 times x minus 1. So then we have y plus 1 equals, distribute the 2 to both terms. You get 2x minus 2, and then subtract 1 from both sides. You get y equals 2x minus 3. And a great way to check it, guys, is if you were to continue this line, hypothetically, it kind of looks like it's going to intersect the y-axis at -3, which is the y-intercept we got in our equation. Okay, so now all I have to do is write it as a singular piecewise function. So we're going to write y equals, and this one has 3 pieces, so I need to save space for 3 different lines. The first line is going to be -x minus 2. That's the equation of the red piece. If the x values are less than or equal to -2. The second piece, the blue piece, it's y equals 2 if the x values, if the x values are in between 2 numbers, -2 and +1. So they have to be bigger than -2, but smaller than 1. And then lastly, we say that the equation of the line is 2x minus 3 if x is larger than or equal to 1. That's it, guys, okay? The last thing we're going to talk about is graphing and writing step functions. And a step function is a piecewise function defined by a constant value over each part of its domain. The graph of a step function consists of a series of line segments, okay? And as you notice, it kind of looks like steps, like there's a person walking here and they're stepping up from one step to the next. Now, one thing I also want you to notice is that each of these are horizontal lines, okay? So when you're looking at the equation of a step function, you'll notice there's no x in any of these equations, okay? You're going to have f of x or y is equal to a set of numbers, okay? Now, how long the line segment is defined by how long your range for x is, okay? So we're going to do 2 problems here. We're going to figure out, okay, what would f of 7 be? And we're going to figure out what would f of 2 be, okay? And we're going to find it 2 ways. We're going to find it first from this function, and second, we're going to use the graph to find it, okay? So the first way, we're going to say, okay, if x is 7 here, okay, what piece does 7 belong to? And I see that 7 is in between 6 and 8, so it would fit right here. And my f of x value is 5 at that point. So f of 7 equals 5. Next one, if x is 2, what would f of 2 be? So 2, a lot of times people get confused and they want to say that it belongs to the first piece. They want to say this one. But unfortunately, 2 is not included because it's less than, the x value has to be less than 2. It's not included in this first piece. So we have to look at the second piece, and this one includes 2 here. So x could be equal to 2 there. So we're actually going to access the second piece and say, okay, it's 3. So f of 2 is actually 3, okay? Now, I want you to look at the graph, and we're going to do both of these from the graph. So let's write them out again. It was f of 7, and it was f of 2. So remember, that value next to the f in parentheses is your x value. So our x-axis, let's go to 7. Here's 7. And let's go up to the graph. Then look over at your y-axis, and this value of my graph at this point is 7, 5. So when your input was 7, your output was 5. So f of 7 is 5. Do the same thing for 2. So we're going to go to the x value of 2, and we're going to go up to our graph. But look, you bypass the open circle because that's not actually part of this line, okay? It's kind of like an open circle showing you that it goes really, really close to this point, but it never actually includes this point. So we're going past that, and we're getting to this point. This point is 2, 3. So when the input is 2, the output is 3. So our value of f of 2 is 3. And you'll notice for both of these examples, we got the same answers. And that's it.